Hello everyone, this is Dr. Marrero from Math Topics. Welcome to lesson number 5 of our mini pre-calculus course. In this video, you're going to learn how to determine if a table of value represents a linear function, quadratic function, or an exponential function, or maybe none of those three. So this is one of the most critical problems in high school mathematics. You present a table of values and you ask the students, without using calculators and any other tool, that determine if the table is linear, is quadratic, or is exponential. This is today's video. I hope you like it. Let's see it. This is the first question. Linear, quadratic, exponential, none. You present this to your students. It's a table of value. It's a function. We have the x values, -3, -2, -1, 0, 1, and we have the y values, f of x, -13, -7, -1, 5, and 11. This procedure is straightforward. You're going to find the first difference. What is the first difference? Basically, subtracting two consecutive values, -7 minus -13, -1 minus -7, 5 minus -1, and 11 minus 5. You check that to see what happens. This is what we call the first difference. The first difference, what I was saying, and look at the beautiful colors that I put here for you. -7 minus -13 is 6. -1 minus -7 is 6. 5 minus -1 is 6. And 11 minus 5 is 6. You ask the students, what happened here? Very simple. We have the same constant value in the first difference. When that happened, the function is linear because the first differences are constant, equal to 6. We can do that in the first time the students learned linear functions. I think it's a little bit in 7th grade and more in 8th grade, and then in Algebra 1. Because this is a pre-calculus class. Very simple, refreshing algebra topics, but it's a pre-calculus class. And it's important that the students gain the ability to determine that immediately. And they understand first difference. First difference is important. If you have a constant first difference, it's a linear function. Let me see what is next. Now we have the following question. Another table of values. X values, f of x values. And we're going to ask the students the same. What type of function is this? Linear, quadratic, exponential, or none? We are giving them only those 4 choices. Because they already know when a function is linear, when the first difference is a constant, now they're going to do the same. They're going to test the first difference. Right here, you can see that -10 minus 10 is -20. -70 minus -10 is -60. Immediately, they see that the consecutive differences are not resulting in a constant number. They can continue if they want, but as soon as they see that one of them failed, they're not equals, immediately they can say that the function is not linear. This is important. What we do, teachers, what we do here is not linear. So let's move to quadratic. And how can we do that? Okay, let's test the second difference. And this is what is coming right now. Look at the first difference that we already did here on this row. And look at the second difference. The second difference is using the numbers that we get from the first difference. This is important. So you're not going back to the original table. You're going back to the first difference. And you're going to do the same. Negative 60 minus negative 20. Negative 40. Negative 100 minus 60. Minus negative 60. Negative 40. Negative 140 minus negative 100. Negative 40. Oh, wow. We have a constant number. So the second difference is constant. Negative 40, negative 40, negative 40. We are not explaining anything here about rate of change. We are not explaining anything here about a slope. We are not explaining here about the graphing representation of the function. It's just a procedural analysis. Because the second differences are constant, this is a quadratic function. This is a quadratic function. Of course, that you can have a conversation with the students and said, okay, first difference, linear. What is the degree of y equals 3x plus 1? That's an example. The degree of that expression, that polynomial, 3x plus 1. Oh, the degree is 1 because the exponent of the x is 1. Beautiful, linear. Associate 1 with linear. First difference with linear. You can have that conversation. Second difference. What is the degree of a quadratic polynomial? X squared plus 3x plus 1. Oh, the degree is 2. So the second difference is constant. You can have that conversation and move that conversation to a more conceptual mathematics, a more sophisticated conversation. But in this video, we are not going to enter in that world. We are going only to tell them, look, this is a procedure to determine when a table of value represents a linear function, a quadratic function, or exponential function, or none. Just that. Of course, the conversation can be part of the teaching and the learning. Linear, degree 1, first difference. Quadratic, degree 2, second difference. This is important. Let's see what is next, no? Now we go over exponential, and I put everything in only one screen. We have the function of values, 1, 2, 3, 4, 5, function f of x, 5, 10, 20, 40, 80. You can ask the students to move through first difference, second difference, and then common ratios. What is a common ratio? So right now we're not talking about differences. We are not talking about subtraction. We're talking about just division, ratios. So we are going to find the ratio between those consecutive y values. 10 divided by 5, it's right here, equals 2. 20 divided by 10 equals 2. 40 divided by 20 equals 2. And 80 divided by 40 is equal to. The students can notice that the x values are in a very consecutive form. 1, 2, 3, 4, 5. And the y values are going by doubling. So 5 times 2, 10 times 2, 20 times 2, 40 times 2. You can treat this as a function because it's a function, but also you can treat this as discrete and continuous data. You can have that conversation too, but I don't want to move into that, just to pay attention to the procedure. This relation, this function is exponential because we have a constant ratio between the y values of two consecutive x. Very simple, very straightforward. Let's see the next one. We have right there another table. What kind of function is this? First difference. Wow. In my first difference, I don't have the same value. I don't have a constant. because the first differences are not constant, it's not linear. They know that. This is the end of the class. Let's see what happened with the second differences. Oh, my second difference, negative 105 minus negative 15 is negative 90, and negative 285 minus 105 minus negative 105 is negative 180. My second difference also fails. It's not quadratic. Let's see what happened, no? Let's test the common ratios. Okay, remember, they test right here the common differences, the first and the second. Let's test the common ratio. Negative 14 divided by 1 is negative 14. Negative 14 divided by negative 19 is just 17 over 2. So the function, we don't have a constant common ratio, so the function is not exponential. This is none of the above. I hope you like the video, and I hope you like the straightforward procedure to determine one of the problems in learning and teaching high school math. And this is important to get this information, to know the procedure, because it's going to help the students a lot in testing, in SAT tests, for example, that they immediately can see the table and they immediately can at least know the type of function they're facing. If you have not subscribed to the channel and you like the video, please subscribe to this channel. Watch the video. Watch the rest of the topics that we present in our playlist. And continue with this mini course about precalculus, which is the beginning of another course that is coming about calculus. Thank you so much. Don't forget, Math Topics membership for this presentation and more resources. Thank you.